Good morning, grade 12s. It is Monday morning, May the 4th, the day that many businesses and things are opening up in Steinbach and in Manitoba. And so there's a little ray of hope in that things are going well with the situation around COVID-19. This morning, though, we do have to start with a little bit of sad news. Many of you will have taken note that over the past 5 weeks, since school let out on March the 20th, I have not shaved and I have let my beard grow. But today is the last day that you will be seeing it. For two reasons. One, my wife really dislikes it. And secondly, when I started growing it on March 20th, I did tell my wife that I would keep growing it until one of two things happened. Either school went back into session, or we hit 20 degrees on the thermometer. And as you will probably know, last Thursday the thermometer hit 21 degrees. And so I must keep my promise, and I will be shaving it on the weekend now. I'm recording this on Friday, so by the time you see this on Monday morning, it will be gone. And this is the last video you'll see with it. So a little bit of sad news. All right, let's get on to what we want to talk about today. We're going to continue our discussion. This will be most likely the last new section that we'll talk about. Again, as I said, we're wrapping up this unit, and there will be a test coming up later this week, probably be posted on Wednesday. All right, we're going to talk about two different things today. The first thing we're going to talk about is units of measure. And when you read, I think it was chapter 3 in your textbook, or was it chapter 4? I only asked you to read a part of it. We didn't read the whole chapter. It was a chapter where you were reading about the effects of radiation on humans. And there's a section at the end of that chapter that talks about the units of measure used in measuring radiation. And I just want to say, and this is all we're going to talk about in this section, is that there are 3 ways in order that we use to measure radiation. And the 3 ways are we talk about radiation exposure, we talk about radiation absorbed, and we talk about a biological effect. And so when we look at these 3 things, and they're on the screen beside me here, the 3 things there, we have exposure, which is measured in a coulomb per kilogram. We have absorbed dose, which is measured in grays, which is equivalent to 1 joule per kilogram. And we have what's called the biologically equivalent dose, and that is measured in a unit called the sievert, which is named after a scientist. Now, why do we have 3 things? Because they each measure a different aspect of radiation. And probably the simplest way to imagine it would be to imagine it raining outside, which may not be tough. It rained on the weekend. Supposed to rain today. But anyways, with rain, imagine you're standing outside in the rain, okay? And the exposure level would be how much rain is there actually, how many raindrops are in the air, okay? That's a level of exposure. So how many raindrops are there? The absorbed dose would be sort of like how many of those raindrops actually hit you. Right? So when it's raining, you know it's raining, you can look outside, it's raining. If you're standing outside in the rain, only a small portion of those raindrops are actually hitting you. So the exposure is the fact that it is raining. The absorbed dose is how much of that rain is falling on you. And then the final one, the biologically equivalent dose, well, that would be equivalent to now how wet are you, right? Because again, you know that there are different kinds of rain, right? It can be a hard rain, it can be a driving rain with wind, it can be just a light drizzle. But again, it's raining, so there's exposure to radiation, there's absorbed dose, how much of that rain is actually hitting you, and then the biologically equivalent dose is the effect that it has on you. So in the case of rain, it's how wet are you. And so that's how we measure radiation. Again, we have exposure to radiation, we have how much of that radiation is exposed, and we have the biological effect of radiation on us. And those are different for different people in different scenarios. And so we just want to be aware of that. All right, the second thing that we want to talk about today is some other applications of radiation. And you're going to do a little bit of reading on this as well, because your assignment today is going to be to read chapter 6, which is a short chapter at the end of the booklet. And there's a few applications that we just want to look at. The first one here is sterilization. Okay, gamma rays are often used to sterilize disposable medical equipment, so needles, IV things, and some other medical equipment, syringes, things that are going to be disposed. So, because even when we dispose of them, we still want them sterilized because we don't want them in landfills and various other places where they still might have things on them that we don't want to get. And so they use gamma rays to sterilize them, to kill all the cells that are on them, the biological cells, and then they can safely dispose of them. A second application, and there's actually many, there's 4 or 5 that are mentioned in the booklet, but a second important one is communications. Cell towers, AM/FM radio towers, and a few other towers like that radiate electromagnetic energy, right? And we saw them on our electromagnetic spectrum. We talked about that. And Health Canada, though, regulates how much electromagnetic energy can be absorbed by people, but through the general public. And it's no higher than 1/50th of the levels that you would see where you would see a biological effect. So while we are being exposed to cell towers and to AM/FM radio towers and other towers, Health Canada regulates the energy coming off of them to 1/50th of where we would start seeing biological effects. So the odds of having a biological effect to standing too close to cell towers or to having lots of cell towers or those kinds of things, there's all kinds of theories around how damaging they are. In Canada, anyway, there are strict regulations on how much energy can be coming off of cell towers. And so the risk to a biological effect from that is very, very minimal. All right, we're going to talk about tanning beds, but as we start our conversation of tanning beds, we first want to start with a discussion of sunlight and natural sunlight and UV rays. We all know that sunlight is made up of UV rays, but did you know that UV rays come in 3 different types? There's UVA rays, which is the majority of the sun's rays. And UVA rays do cause some damage, but they're the ones that are responsible for premature aging, wrinkles, those kinds of effects on your skin. UVB rays are the ones that cause the most damage to our skin. UVB rays are the ones that will actually penetrate into your skin and are the major causes of sunburn and of skin cancer. They're the ones that destroy our cells. And they are 1,000 times stronger than UVA rays. And then there's UVC rays. Now UVC rays never reach the Earth's surface. They are filtered out by our atmosphere. So we don't need to worry about them. All right, so we have UVA, which is the makes up the most of sunlight. UVB rays are the ones that cause the most damage. Now, tanning beds. Tanning beds make use of UVB rays. When you go into a tanning bed, you are exposing yourself to UVB rays because it's the UVB rays that give you that nice tan. And too many UVB rays cause a burn. So UVB rays are the most damaging part of sunlight. Now we're taking that out, and instead of having a mixture of UVA, B, and C, we're taking that out, and when you go to a tanning bed, you are only exposing yourself to UVB rays. And so the answer to the question, should you use a tanning bed? The answer is no. A couple of stats for you. Here we go. And again, now the tanning bed stats are often focused on women, but it's no different for men. It's just that women tend to use tanning beds more often and more frequently than men. And so here's a little picture. It says that the use of indoor tanning equipment before the age of 35 leads to a 59% increased risk of getting melanoma. Melanoma is skin cancer. So if you use a tanning bed before the age of 35, you have a 59% greater chance of getting melanoma, right? And then there's a stat there that says 27% of young women use indoor tanning equipment. All right, so again, don't use indoor tanning beds. A second stat, again, study of women, but it says here that one study observing 63 women that were diagnosed with melanoma found that 61 of them, or 97%, had used a tanning bed. All right, so 63 women under the age of 30 that had melanoma, 61 of them had used a tanning bed. So there's a direct correlation to tanning beds and an increased risk of melanoma, and so it is not a good idea to use tanning beds. All right, that's all we have for today. Your assignment is to read chapter 6 in your student booklet. It's a bit shorter. And if you haven't watched the videos on the various things, you can try to watch them. I know some of you were saying you had problems with that, but we want to go for that. I want to end today with, again, a verse of the day. And again, on Friday when we had our Thursday when we had our chat, I talked about knowing that Jesus is with us at all times. And so today, out of Psalm 41, so I want to read you a verse here. It says, Psalm 41, verse 10 says, "So do not fear, for I am with you. Do not be dismayed, for I am your God. I will strengthen you and help you. I will uphold you with my righteous right hand." So talked on Thursday about the I am, that Jesus is with us. He says, I am with you. And here's another verse where Jesus says, I am with you. So be encouraged by that, and we will see you tomorrow.